Okay, for your question 16, be very careful. The Brownian motion of the smoke particle is caused by the collision between the smoke particle and the air molecules. Okay, it is not due to air current because it's done in an enclosed box. It is not due to collision between molecules because you can't see molecules. They are in like less than nano scale. The smoke particle on itself doesn't vibrate. Okay, so therefore the answer is D. Okay, down here on question 17 is about heat transfer. So why do the paper does not get burned is because whatever heat energy that is supplied to the candle is being conducted away from the paper and to elsewhere. That's why the paper doesn't get that increase in energy because all the energy is being conducted away. So therefore it's because of C, metal being a good conductor of heat. Okay, question 7, you need to know one thing. When you are doing thermocopper, the law that governs it is actually the difference in temperature is directly proportional to the EMF, that means the voltage. Now, be very careful, this is in millivolt. So, okay, anyway, since this is in millivolt, this is in millivolt, not much of a problem. So, they give you the first case whereby the difference in temperature is between pure melting ice to boiling water. So you know that the difference in temperature is 100 degrees C and it will generate a EMF of 8.4 millivolt. So with this, okay, this thing here basically is telling you that your difference in temperature is equals to kV. Okay, this is the constant. And the first case, you can substitute this value in to find the K. Okay, so now you know that the K is actually 100 divided by 8.4, which will give you around 11.95 like that. Okay, so with that you can put in your case number 2 whereby the difference in temperature you do not know, and the EMF in this case becomes 6.8. So put in the thing, you do not know what is the difference in temperature, but you know the constant from the previous calculation. You also know that the EMF generated this time is 6.8, so you'll be able to get 80.95 degrees C. But remember that this is the difference in temperature. It is not the temperature that you are measuring. So difference in temperature, so that means that we need a reference point. So here you read the question that junction Q is left in the boiling point and then junction P is placed in that unknown liquid, meaning that your difference in temperature makes up of two parts, right? Your delta T is actually make up of the temperature in P, or the temperature in Q minus the temperature in P, okay, as long as the difference. Okay, so the difference is 18.95. You know that the temperature Q is in boiling water, so this is 100 TP. So your temperature P is actually equals to, okay, 19 degrees C. Okay, that's why your option is A. So be very careful towards the last part. It's the difference between temperature. Okay, your question 20. Hot water at 100 is added to 8 grams of ice, blah blah blah. What is the minimum amount of hot water needed to melt the ice completely? So this one is actually your heat exchange formula, meaning that your energy lost by the hot water must be equals to the energy gained by the ice. So we can assume that the 100 degrees C water will be turned to 0 degrees C. Okay, that there will be instant heat transfer and there will be no heat loss to the surrounding. So down here, just express this E loss into your specific heat capacity formula. So E equals to MC delta T, right? So do the same thing. E equals to MC delta T. And the energy gained by the ice will be the mass of the ice multiplied by the latent heat of fusion. So now let us put in some numbers. So the mass of the ice is actually 8 grams I do not need to change this to 8 kilogram because the latent heat of fusion here is per gram as well. So that will take care of the SI unit. So down here it says that it's 336. So I'm comfortable with that. I'm supposed to find the mass of the hot water, so I do not know what is this mass. I know the specific heat capacity because down here again in gram, so it will be 4.2. The difference in temperature, I assume that there's no energy loss to whatsoever and the heat transfer is instant. So it will be 100 minus 0, which is 100. So solve this equation, you get the value for M. You will get 6.4 gram. So there you go, answer B.